Yeah, hey everyone, I'm Matt Martz. And this talk is Say Goodbye to Your AWS CDK Stacks, A Guide to Self-Destruction. I'm a big CDK fanboy. I love serverless and event-driven architectures type of stuff. So I don't know, this one came about as part of my work at Power School. So I'm a principal engineer at Power School. I'm also an AWS community builder. AWS Community Builders is a program that AWS puts out to essentially create a network of people interested in AWS. It's a great networking opportunity. You can apply to the program. You feel free to ask me about it later. I'm not going to go, the presentation's not about that, but it's an awesome program. I've been a member for three plus years. I'm an OG. I've made a CDK crash course for freecodecamp.com. It's on YouTube. There's a short link there. I also have a blog where I blog about CDK stuff, serverless stuff, event-driven architecture stuff. It's at matt.martz.codes. And there's a short URL that I created, martz.codes/b/destroy. And it points to a blog post that goes along with this presentation. It includes the code examples and stuff like that. So, hi. I'm also from DC. So we're going to talk about CDK a little bit. We're going to talk about ephemeral stacks, what ephemeral stacks are. We have the AWS community builders have an AWS community scope for NPM libraries. We also have a GitHub organization where we can post code to. So I put out a library for this self-destruct concept on there. And I'm going to walk through kind of how I made the library, which includes CDK aspect, what an aspect is, a construct, and stack, along with kind of how we can extend it and how we can use this as part of CI/CD. So just a quick poll of the audience really quick. How many people, when they create things in AWS, do you do ClickOps, like go through the console and create things via the console? Show of hands. How many people use vanilla CloudFormation? You make YAML, templates, that kind of thing? Okay. How many people use CDK? Okay, good number of hands. And then how many people use something else like SAM or Pulumi or Terraform or something like that? All right, cool. So CDK is a cloud development kit. It's an AWS offering. It's open source. You can look at the code on GitHub. And what it does is it enables you to write code to generate CloudFormation YAML. That's pretty much it. It supports a number of different languages, and you get the power of being able to write imperative code to generate that declarative YAML. So you can do things like for loops. You can create a list of, like, I want 6 buckets with this naming convention. It'll loop through, create all the buckets. Super easy. CDK also takes care of a lot of the policy and role creation type of stuff, the IAM stuff for you, or it makes it a lot easier too. So when you create a CDK bucket, for example, if you want to grant read access to that bucket from a Lambda function, what you can do is you can say, bucket.grantRead, and then put in the function that you created with CDK, and it takes care of adding the policy statements to the Lambda's execution role. So what are ephemeral stacks? Ephemeral stacks is, the concept of having a CloudFormation stack that maybe it's a developer's personal stack. They're working on your project. They need to do temporary work on a branch. They want to deploy their self-contained stack themselves, and then ideally the developer will destroy it. But let me tell you from my personal experience, probably in April when I originally created this self-destruct code base, at Power School, I went into probably 15 of our AWS accounts and had to delete over 200 CloudFormation stacks because they hadn't been updated or touched in months. Now, we're a serverless first organization, so that wasn't necessarily a big cost, but it does eat into resource quotas and things like that. So, it's always a good idea to clean up after yourself, but you can take this a bit further and use ephemeral stacks to do your integration testing. So you could deploy an ephemeral stack as part of your CI/CD pipeline, run tests against code that should be functionally equivalent from all of your other infrastructure, and then it will delete itself without you having to do anything. So that is the general idea behind ephemeral stacks. So when should you use them? Ephemeral stacks, so I already went through the developer example. There's a lot of cases where if you're working on a branch, you're trying to add a feature to a project, if you deploy your own personal stack of something, you can have a pretty aggressive policy on how soon to delete it. So in our org, we generally set the policy to have a seven-day policy, so 1 week. If a developer doesn't push an update to a stack in a week in our development AWS accounts, the stack will delete itself. That probably implies they're done with that feature, they're done with that branch, they're done with whatever, right? So when do you use it? I mean, it depends, right? Developer stacks are a great example of that, but ultimately you need to look at like the lifespan of the things inside of it. If it is something like you're working on a feature and you're not going to need it later, if you are creating a bucket, for example, and the contents of that bucket are something that are generated by code or from static files or something, that's great. You won't need to keep the bucket around for no reason. You can also identify, you also need to establish the cost. In my example, or when I talked about deleting 200 stacks and being a serverless first organization, I mean, it was a lot of lambdas, and there's no cost for keeping lambdas around if they aren't being invoked. So that's another factor, but you can start hitting function resource limits and things like that. You also need to kind of evaluate if something could be inside of an ephemeral stack if it's being used by other things, right? Like if you're using resources cross account, cross stack, that kind of thing, you don't want to have this ephemeral stacks deletion policy be too long or too short that the stack gets deleted before whatever's using it is actually still deleting it. And critical path. Obviously, you don't want to delete critical path things. You probably also don't want to have an auto-delete policy in your production accounts, for example. The way I set it up with my aspects and everything is the stack actually, you whitelist the accounts that it's okay to delete things in. And the way CDK handles that is it won't even include the step function that deletes the stack if it doesn't meet that criteria. So it doesn't, like CloudFormation never even sees it because it isn't synthesized into the CloudFormation template. So, all right. Factoring this into like a common continuous integration, continuous deployment scenario, this is what a typical company's pull request and main branch deployment CI/CD type pipelines look like. You prep. You do the install, you unit test, and you do all that kind of stuff. And then if you do integration testing, which sometimes you don't, usually you don't deploy a CDK stack to do it. Usually you spin something up like local stack inside of a Docker image and run everything internally inside of that and call it good. Some people do deploy things, but those are part of like a QA environment or some long-lived environment that's not ephemeral. And if there's some bad code in that impacts things in the database or whatever, it could effectively make it dirty and make things that run after it not work, right? So that's an example for a pull request pipeline. For a main deployment pipeline, you probably are doing kind of the same things before, and maybe you'll run like a smoke test or an integration test against your QA environment. But you run the risk of having maybe if there's a failing test or something and it doesn't clean up after itself, you might inject bad data into the environment, which could cause things later, future pipeline builds to fail, right? So if you update these pull request pipelines, for example, you could deploy an ephemeral stack to do this integration testing with, and it's a clean slate. So you can use real infrastructure for your tests, and you can even make them asynchronous and do all this stuff outside of the CI/CD pipeline so that it's not impacting the rest of it. So you can maybe have it run the CI/CD pipeline deploys it for the pull request, runs the test against it asynchronously, and your CI/CD pipeline isn't continuing to run, it's done. But then you can have something report back on the success or failure through other means. And then it will delete itself and clean itself up. For main CI/CD pipelines, I mean, I don't know, debatable whether or not you actually need to relint and reunit test your pipelines, because you probably already did that by pull request, but I know we're guilty of that myself, so it's a nice safety net. But again, you can simplify the process and kind of cut out some of these steps, and it doesn't seem like it saves a lot of time, but like the hours can add up, especially if you're doing it on the pull request side. Yeah. Oh, sure. So there's a big explanation of this in the bumper on the bottom corner too. So I can also reach out, if you reach out on Twitter, I can also send the slides to you if you miss something. But so let's talk about the construct library that I made. So it's available on GitHub. It's available as an NPM library at the AWS community scope. So you can NPM install it. What it does is it exports three things. It exports a CDK stack, which includes the aspect and the built-in stuff into it. It includes an export of the aspect in case you just want to use the aspect side of it. And it includes the construct, which creates a step function, which does the deletion. So the way the step function works is when it runs as a custom resource. CloudFormation has the concept of custom resources that can run as part of a deployment. And it will invoke something. So in this case, we're invoking a step function with every CloudFormation deployment. What it does is it lists executions of itself that are running, and it will, if there are running executions of it other than itself, it will stop them. And then it sets a wait timer. So there's a wait step in step functions that, I mean, that's what it does. That's all it does. Once that wait period expires, then it will delete the stack. So every time, if I deploy a stack once, it will not find any running executions of itself, won't have anything to stop, and it will just wait for 7 days or whatever. And at the end of that, it will delete. If I deploy another update of the stack, say 6 days in, it will see the previous execution, stop it, which kills the wait, and it won't delete anymore. And then it will continue on and, again, effectively resetting the timer. With step functions, you're not paying for how long they run. You're just paying for the number of iterations that they go through. So this is a kind of easy way to keep things running. At work, we've actually improved this a bit, and we actually have a project that monitors things externally, and we use DynamoDB TTLs to kind of do a lot of this for us. And it abstracts it centrally, but that will be the topic of a future talk. So how does this kind of work in the background? An important thing about ephemeral stacks is the resources need to be they need to be set to be destroyed. CloudFormation has the concept of a retention policy for most resources, and you can either retain them if the stack gets destroyed. An easy example of that is a bucket, or you destroy it as part of the CloudFormation stack being destroyed. There's an interesting quirk for deleting buckets, for example. If the bucket deletion policy is set to delete, and there are things inside of the bucket, what happens is CloudFormation will blow up because the bucket's not empty. CDK has a nice feature where for the bucket, if you create it with CDK, you can set a property called auto delete objects, and you can set that to true. And what that will do is it will create a custom resource that when the stack is destroyed, it will invoke a Lambda function. The Lambda function will empty the bucket, and then it will continue, and then it will delete the bucket, and everything will be fine. So what the aspect, this CDK aspect, what it does, sorry, CDK aspects, what are they? Yeah, thanks. CDK aspects are, it's a way, there's a blog post linked on this one that goes way into much greater detail on what aspects are, but as the CloudFormation template is getting synthesized, it basically goes through each construct, so like bucket construct, pretty much everything you're creating in the stack, and it allows you to either validate things or modify it, that kind of thing. So in this case, the visit method is getting called on every single thing that's in this CloudFormation stack. And it's either setting the retention policy to delete, but it's also checking if it's the case that it's a bucket, it's making sure that that auto delete policy is set to true. You can't have it you can't have it set the auto delete policy to true for you, because that's a level 2 construct, and it's not something that CloudFormation natively offers. It's something that CDK adds onto it, and it's too late in the process at that point in order for it to add it. So yeah, so the aspect goes in and make sure the stack is fully removable. That's the gist of what the aspect does. The construct is similar. A CDK construct is something like they have different levels. There's a level 1 construct is the same API as the CloudFormation APIs for a specific resource. So a CDK bucket, for example, the level 1 construct for a CDK bucket is CFN bucket. That's what it's called in CDK. And the API is exactly the same as what the CloudFormation like YAML API is for a bucket. A level 2 construct improves on that. A level 2 construct improves on that. It wraps the level 1 construct and then adds maybe some sensible defaults, or it adds the things like the auto delete objects option to the construct, and in this background that will create it might create custom resources or do whatever it needs to do in order to add those features. And then the last level is a level 3 construct, where it's just a grouping of level 2 constructs. So this is a level 3 construct. So what it does is it creates that step function, and it creates the custom resource to run the step function as part of your stack. The last thing that the library produces or exports is the stack itself. So the stack simply includes the construct, and it includes the aspect as part of it. So you could import this stack into your project and extend it, and then as you add your own resources to it, all of these things will be baked into it. Alternately, since the other things are exported, you could also just cherry pick. Like I don't want the step function. I just want the aspects. You can import the aspect into your project and do that as well. So the blog post goes into a lot more detail on that, and it links another blog post that goes into more detail on how the actual step function everything was created, and there's another blog post that goes into detail on the aspects. So, how to self-destruct. I guess that's kind of readable. It's not readable for me. So basically there's the two ways. This is it. I mean, you can either extend the stack or use the construct inside of your existing stack, what I already said. Switching gears a little bit, if you were to integrate this into your OIDC pipeline, into your CI/CD pipelines, I strongly recommend using OIDC. OIDC is OpenID Connect. It's a way to connect it'll basically create a role that your CI/CD pipelines can assume without you sharing secrets to like GitHub or GitLab or whatever. It creates a direct connection between GitHub or GitLab or whatever, and anything that supports OIDC and AWS. And it will assume the role and fetch temporary secrets instead of creating a long-term user for them to use. Matt Morgan did a great talk on IAM for serverless developers yesterday. I think these videos will get posted at some point, so definitely go check his stuff because he goes into more details on the IAM side of it. But I realize that's a little hard to read on the screen. Basically, it's a CDK construct to create the role, and then you would just be able to put the role ARN into your CI/CD pipeline in order for things to run without you having to have secrets in place. So, all right, I did that. I did it for both GitHub and GitLab. I added it to a project, and since I didn't know how well the internet connection would be here, I I'm not doing a live demo, but what I did was I pushed a commit with the simple project. It created the upper part where it creates the stacks. I use dark mode in the AWS console, so not everything supports it though. So it ends up creating the stacks as part of the CI/CD. Between that top image and the next two, that top image was done by the CI/CD stuff. But then at that point, like that's it. The CI/CD pipelines ended, and these things happened async after that. And I think I had the stack set to delete after 5 minutes or something. You know, you wouldn't want that short of a period, but for demo, it would be fine. So the commit went, CI/CD deployed the stack. That was it for CI/CD. The custom resource ran the state machine. Once it was done, it deleted itself. Easy. And you know, that's my talk. I think ephemeral stacks are a really powerful thing that you can use as part of your developer experience flow. So yeah, definitely check it out. Thanks.